Yeah.
I just marked you out.
Oh, really? You give them practice, or is it gonna be like in gym or something? Really? Maybe like wipe out the kiddo.
All right, let's take a look at practice test number 2. Okay, looking at practice test 2, let's do a couple of things first, and then we'll do whatever it is that you feel like we need to practice. But first, let's take a look at the word problem, the linear programming problem. This is on practice test 2. So this one has to do with audio players and phones.
What problem are we on?
We're on practice test 2. Problem number, I don't know what the number is, but it's the word problem. All right, so here we go. You have read problem number, or whatever problem number this is. You've read it. Now it's time to start filling in stuff. So one sentence at a time. It must make a minimum of 600 players, 800 phones, and a maximum of 1,500 players and 1,700 phones. Stop right there. What are you going to do with that information?
For the number of audio players, you got 600.
Okay, now let's look at it. It's minimum
Oh, that'd be
600,
fixed interval.
maximum.
So it'd be 600 less than X, less than 1,500.
Yep.
Then in the other one, it would be 800 less than X, less than 1,700.
And we'll use Y for this one.
Y.
Yeah. So, because X is going to be our audio players, Y is going to be our number of phones, and we know X has to be in this interval and Y has to be in this interval. So I am actually going to graph those intervals on my calculator, on my grid here. And I know that when I do that, I'm going to do that with bars, right? Either horizontal or vertical
Bars.
All right. Next sentence. The cost of an audio player is $55 and the cost of a phone is $95. $55, $95. At least 2,000 items must be produced per shift. How many of each type should be made to minimize? This might be our first minimize. We want to minimize the cost. And what is the cost equation here going to be? 55x plus 95y. Now, what is the fact it's a minimize? What does that mean? What will be different?
We're trying to find the smallest amount.
Exactly. When we get over here and we get it graphed and we have our points and we plug in and get all those numbers, we're going to be looking for the smallest one this time, not the biggest one. Okay? All right, so is there anything else I need to graph? I think I need to graph this. X plus y Now, be careful, at least 2,000. Greater than or equal to 2,000? Javon? Hey.
Sorry.
Okay? Now, let's graph it, and looking at the size of those numbers, well, tens aren't even gonna be big enough, are they?
100.
Hundreds?
200.
I think we should just make 200.
200? So when I graph 600 to 1,500, if these are all going to be worth 200, then this is where 600 will be. And that's 8, 10, 12, 14. 15 would be in here, right here. Okay, Suzanne and Abby, do you think maybe you should be paying attention? Okay, and then for my Y's, I am between 800, here's 800.
How much do you choose?
And this is 8, 10, 12, 14, 16, here's 1,700. So what have we got so far? We have to be in between these two and in between these two. Are you looking at this box right here? Now we got to graph this one. Get out a different color here. I'm going to graph that one. And how do I graph these diagonal ones again? What's my strategy? I let x be 0, so then y would be 2,000, which is right here. And I'll let y be 0, so then x would be 2,000. And I'm going to draw a nice straight and where is that shaded? Where is my purple line shaded? Above. So I'm inside the box, but above the purple. Does it look like you have those corners? If you're inside the box, but above the purple?
Wait, I thought we were trying to minimize.
Okay, but the equation, we are, but we're not ready for that yet. The equation is at least 2,000.
Gotcha.
So I'm graphing this equation.
Gotcha.
Now, when I find all of these points, I'll look for the lowest value.
Gotcha.
And there are, how many of them? 1, 2, 3, 4, 5 again? All right, so here we go. Some of those are really easy to find. If they are the intersection of a horizontal and a vertical, then it's a no-brainer. This point, both of these points have x coordinates that are 600. Right? Now tell me about the y coordinate at this point. That one's 1,700. So one of our points is 600, 1,700. Now what about the y coordinate of this one? Its x is 600, but it's on the diagonal. So if x is 600, what would the y have to be if x is 600? 1400? Let's look at these 2 points. We know their y is 800, right? What is the x for this vertical one here? The x is 1500. So one of our points is 1500, 800. Now this one's on the diagonal. So its y is 800. What would its x have to be?
1500 or 14. Which one? 1200.
If y is 800, what would y have to be?
1200.
1200. And finally, this guy, who's an easy one, we know x is 15 and y is 17. So we have these 5 points. Everybody okay with those 5?
Yeah.
Now what are we going to do with them? Kaylin? Plug them where?
Oh, see,
Into the thing you want to
see which one's
minimize.
the least.
And we're going to plug them in here, 55x plus 95y, and whichever one gives us the smallest answer this time wins, okay? So I want you guys to do the first point. I want you guys to do the second point. Julia, with this front row right here, you guys do the third point, you guys do the fourth point, you guys do the last point. Get the value so we know which one's the smallest. Anybody got a point for me? 244,000. Which one? The third point is 244,000.
I got one.
Anybody else have a value?
The first one. 194,000.
Did you the first one?
Yes.
Okay. Anybody have another one? Kieran?
142,000.
Will you this one?
Yeah.
That's the winner right there.
What'd you guys get? Bryce, did you get a point yet?
Which one?
This one?
166,000.
166. And you guys in the back, what'd you get for the last one? 158? So, according to your numbers, which I have no idea if they're right or
The
not,
last one we got
the answer,
194,500.
the answer would be right here. So we should make, and we write this down, we should make 1,200 audio players and 800 phones.
I would say everyone to minimize.
Is there kind of just a shortcut to do that? Like you just take the 95 is the bigger number, and you just take that with the smallest y, which was 800, and you take the 55, you take the smallest one too.
Okay, we talked about this the other day. What you choose to do or not do over here is up to you. Just know that if your logic breaks down or you make a mistake and you don't have any work shown and you had the wrong answer, there's a lot of points to be blown here. So if there's time to actually do the calculation, I would do it. If you want to rely on your logic, which is good, there's nothing wrong with it, except if you make a mistake, there's nothing for me to grade, and so there's no partial credit.
All right.
That's my only caution. Your logic is fine. It's good to be logical. All right, so that's good. Now the other one I want to do right now, okay, right here, sorority girls. This is going to stop. Now, okay, this is on video, so all I need to do is email Mrs. Baumgartner, Mrs. Fox, Mrs. Brady, and Mrs. Henry, and Mr. Henry, and say, would you watch this video and see how attentive your daughters are being in class? I don't think that would go over very well, especially since 3/4 of you do not really have grades that are exemplary.
Gardy Savage.
You know, sometimes the truth hurts, but we have to face it. All right, now let's take a look at the calculator problem.
She said on all your faces. She said, eat it.
Get out your calculators.
Hold on, your class, about 9/10 of this class is gonna have me in the summer.
Yes, unfortunately.
You're all laughing,
Wait,
but
can you still graduate if you take a wait?
yeah, you can still graduate if you take summer school. She said, I'm cool with it. Okay.
I don't want to be in something.
Yeah, that's not tight. I did that one time too many. Yeah, I took summer school, no shame in my game.
All right, now, I am doing problem 8, which is the calculator problem. You will have a problem exactly like this. This practice test is what your test looks like. So we just did a whole page problem. Now we're going to do another whole page problem, but this one's a lot easier. This is problem number 8. It says use a calculator. So you will notice that the first thing I've done, and you have to write this down to get credit, you have to show me what you're putting into the calculator. This is the matrix that's going in. You will notice I've got some zeros in here. Why is there a 0 in this spot right here?
Because there's no D.
There's no D in that equation. I've got to pay attention. There's no D. And then there's a 0 here because there's no B. Does everybody see that? A matrix is a rectangular array of numbers. You got to have it all filled in. You can't have gaps. So if something's missing, you're going to put in a 0. All right, so we're going to get all that put in. And then we're going to mess around with it, and another matrix is going to come out. And I need to write that down too.
Okay, you do you.
Okay, so does everybody remember how to do this?
Yes, ma'am.
If not, would you lean over and ask your neighbor? What are the dimensions of this matrix?
4 by 4.
4 by what?
4 by 5.
4 by 5.
Man, if you don't get on somewhere.
This says Wednesday or Thursday? Thursday?
Wednesday.
Ain't econ on Wednesday?
Yeah, I actually have a government test on Wednesday.
Yeah, no, I'm not ready to go.
Government?
Let's not talk about that.
It's gonna be guessing. There's some D's on
What do you
it.
have?
C for you.
What's your point to it? It's so bad.
Ballin'. Swoosh. I'm sorry.
Oh my goodness. Have you gotten your final matrix?
Not yet, just hold on, just hold on.
How cool is that?
This is so cool. Wait.
I got it.
Oh my gosh. You knew what you were doing, you little sly little. Look at her.
So the system has a solution of 1, 2, 3, 4. And what is on the board is what should be written on your paper. You do not have to write anything else down. The calculator does all of the work. All you have to do is show me what you put in, what came out, and what the answer is. That's it. Maya? You don't have to have a dash line there. I sometimes put that in to remind myself that that's really where the equals is. These are the, what are the A's, B's? These are the A's, B's, C's, D's, and then these are the equals numbers. It doesn't matter. You don't have to put that in there.
Oh, yeah.
Okay, now, so we just did the last 2 pages of the test. There are 3 more pages. Let's run through number 6, which is the vocabulary.
Okay.
And then we'll run through anything else you personally feel like you need practice on. So let's look at page 6.
I already know the first question I have.
Okay, so on page 6, or number 6, I mean not page 6, number 6. Answer the following. Number A, what is A sub 1, 2? 4. That means first row, second column, what's the number in that spot? That would be 4. What are the dimensions of A?
2 by 4, 4 by 2.
What are the dimensions? 4 by 2.
Ooh.
There are 4 rows and 2 columns. Remember, your dimensions are always rows, columns. In the expression 3A, 3 is called a scalar. Very good, Bryce Acridge. It's called a scalar. Is A square? Why or why not?
No.
No.
Its rows don't match its columns.
Because it has a different number of rows than columns. That's right. To be square, you have to be same number of rows as columns. So 2 by 2, 3 by 3, 8 by 8. Define matrix. Jabron.
A set of numbers arranged in rows and columns.
Close enough. A rectangular array of numbers arranged in rows and columns. A rectangular array of numbers arranged in rows and columns. Any questions about part 6?
Part 4. I'm ready to go.
So you want to practice part 4?
Yeah, just a little review, a little quick little flashcard session.
Okay, so part 4. Now there are lots of problems here. What does A mean? When we say this notation, what does that mean?
The inverse of
The
A.
inverse of A. And A is the matrix 1, 2, 3, negative 4. Now, finding the inverse is a 2-step process. Let me say that again. Finding the inverse is a 2-step process. It's going to be 1 over something times the new matrix. Now, what's the something? 1 over what? What number is going to go here? The determinant. And what will the determinant of that matrix be? Negative 10. And for those of you that have forgotten how to do a determinant, remember, it's this minus this. So it's negative 4 minus 6. Now, this new matrix you're going to build, what do we do there? We take these 2 guys and switch them. And these 2 are both positive, so they're going to become both negative. Then we simply put all these over the negative 10. So that would give us 4/10, 2/10, 3/10, negative 1/10. And then this one I'll have to reduce. 2/5, 1/5, 3/10, negative 1/10. That is your inverse. We had a quiz over that, remember?
Yeah, but I kind of forgot.
I know. That's why I keep emphasizing finding the inverse is a 2-step process. 1 over the determinant and then this new matrix that you get by switching things around. Okay, let's look at problem B. What is problem B asking me to do?
Multiply 2 times matrix C.
That's right, which is very simple to do. That just means 2 times everything. So 2C would be 246, negative 228. Nobody should miss that, right? That's easy. 3 is a multiply problem. It says multiply A times C. Now before you jump in, you better make sure you can.
Yeah.
In order to determine if it's possible, we need the dimensions. What are the dimensions of this one? 2 by 2. What are the dimensions
2 by
of this
3.
one? Uh-oh, and the rule is these two have to match. And they do. So that means that we are able to multiply, and when we do multiply, we will get another 2 by 3 matrix. So it will have 2 rows and 3 columns. Now, to fill in this spot, this is in the first row, first column. So we are going to multiply the first row of numbers by the first column of numbers. See how this has 2 numbers and this has 2 numbers? We take first times first, second times second, and add them together. So 1 times 1, 2 times negative 1, add them together, that would be negative 1. Now you might need to write that down, and that's okay, just over to the side. 1 times 1 plus 2 times negative 1. Now we're ready to find this number. Well, where is he? First row, second column. So we'll take 1 times 2 and 2 times 1. So that adds up to 4.
Wait.
This is in the first row, third column. So first row, third column. First times first, that would be 1 times 3. And second times second, that would be 2 times 4. So that number is 11. Now, are we going to do exactly the same thing now? Yep, only instead of using the first row, now we're going to have to use the second row. But you're going to take the second row times the first column. So 3 plus 4. Second row, second column, 6 minus 4. And second row, third column, negative 7. 9 minus 16.
What?
Remember, you can't always multiply. These have to match to be a multiplication problem, doable multiplication. Okay, look at D. A plus B. Not possible. Why can you not add A plus B? They don't have the same dimensions. John Tarander's missing.
Johnny. Ron, that's what I'm saying.
Yeah, just so it sounds like a famous name.
Who's that? Oh, this is John Toronto.
Okay, E.
Yeah.
D is not possible because they don't have the same dimensions. E, we're going to multiply B times D. Whoa, 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 wait a minute. What are the dimensions of B? 3 by 3. What's D?
2 by 2.
2 by 2.
No.
In a 3 by 3 and a 2 by 2, these two don't match. Can't do it. Impossible. On your test, you will have some impossible questions, and you just write can't do or impossible.
What if it's a problem that I just don't understand and I physically and mentally can't do it? Can I
Okay,
do that?
if there's an answer and you say impossible, then you're going to miss it.
Oh, okay.
Okay, F.
This is just impossible for me.
2D minus A. All right, so what am I going to do first? I have to do 2D minus A. So I'm going to take everything in D times 2. So negative 4, 2, 6, 12. Is that okay for 2D? And I'm going to subtract A. Now that is doable because these are the same size. Right? So here we go. Negative 4 minus 1. 2 minus 2. 6 minus 3. 12 minus negative 4. Any more questions about part 4? All right, what else do you feel like you need to do? 1, 2, 3, or 5 really is all that's left. Substitution, number 1. Number 1.
Okay.
We're still on practice test 2. We're doing problem number 1.
What it do? But to learn me some pre-cal when I get to school. Some bar.
Okay, Suzanne Fox,
That was my turn.
I want you to move back to this seat, right back here, this empty seat. Okay, directions say substitution. Okay. What does that mean, substitution? What do I do? I'm going to get one of these by itself. Now, as I'm looking at these, this looks like the best choice to get by itself, right? Because it's a plain y. So I'm going to subtract, so y equals 5 minus 2x. I'm going to cross this equation out because I've rewritten it this way. And I rewrote it that way so that I could take this and plug it in right here.
I feel you.
Substitute it in. So 3x minus 2 times 5 minus 2x equals negative 3. I simply take the value I got for y and put it in place of y. So 3x minus 10 plus 4x equals negative 3. 7x minus 10 equals negative 3. 7x equals 7 and x equals 1. Now we're so excited,
Can I do the second part? I just
but
solved it.
we aren't done, are we?
Can I do the second part? I just solved it.
Okay, the answer is an ordered pair, and we figured out that x is 1. So Gibran, how do you do the second part of the problem?
You take the 1, plug it in for x in the first equation, then you get 2 plus y equals 5. Subtract the 2 over, y equals 3.
Okay, now Gibran said, he did a great job, But he said plug it back in the first equation. Do you have to plug it into the first equation?
But
No.
should you?
I think so. I think it's
Yes.
the easiest, but
So-
you don't have to. You can plug it back in anywhere.
I think. I know.
Gerard? All right, who else has a question? 2, 3, and 5 are the ones left. 2 is another system, but this time we're solving it using elimination. So remembering that our job is to eliminate a variable, what do you think will be the easiest?
Multiply the bottom by 3.
Negative 3.
Tyler says multiply the bottom equation by -3.
Yeah. Yeah.
Now, you may or may not go that route, but you understand what he's trying to do? He is going to have, in this bottom row, he's going to have 15x minus 3y equals -30. Multiplying everything by -3. His top equation is staying the same. Look what happens right here. Those are going to go away when he adds. So 17x is going to equal -34. And x will equal -2. Now again, you are not finished.
No, you're not.
You're an ordered pair, and the x is -2. But you do just what Jabron did a minute ago. You take that -2 and you plug it back in somewhere, anywhere. If I just put it into the top equation, because this is there, it's on top, I would have -4, because I'm putting in -2. So I have -4 plus 3y equals -4. Wait a second. That would give me 3y equals 0. What does that mean?
It means y equals that.
It does, y equals 0.
All right, I think that's enough for today.
No, I want to see Cramer.
Yep, we're going to do Cramer's rule, and then you'll only have one problem for homework. All right, at least we're going to get as much of it done as we can. Here we go with Cramer's rule. How do we start? What do we do first? Who remembers Cramer's rule? I set up a determinant of my x and y numbers. So here's my equations. So my x numbers are 3 and -2, and my y numbers are 1 and -5. Everybody see what I'm doing? Making a determinant out of the coefficients. Now what's the value of that determinant? We need to figure that out. That would be -15 minus -2
-13.
or -13. Now what do I do with the -13?
That's the denominator.
That's the denominator. Remember, you're going to have an ordered pair, an x and a y, but this time they're going to be fractions, and the denominator is going to be -13. Are you remembering this?
Yeah.
Now how do I get my numerators? They are determinants also, right? And when I'm picking the x1, I take these two numbers and I glue them on top of the x row, column, right here. So I'll have 7, 1, 1, -5. When I'm doing y, I do the same thing, only I put them here. So I'll have 3, -2, 7, 1.
And that's the answer.
No. Now I evaluate. So I have -35 minus 1. That's -36 over -13, which becomes 36/13. because the negatives cancel. Here, I get 3 minus negative 14, I get 17 over negative 13. There is the ordered pair, that's the answer to the question. Thomas, can you show yourself there? Now, it's really, really easy to sit there and watch Mrs. Ford do the problems.